Hey there, in this video we are going to be defining a function that will be able to express an improper fraction as a mixed number. So we have a little bit of problem from the beginning because we're not able to express a fraction because we end up with these floating point values. So to fix this, we are going to import a function from SymPy. We're going to import rational. Now that's with uppercase R. And what this will enable us to do is use this rational function that has two arguments, a numerator and denominator. So we can see here that this function returns 1/2 as a fraction, and maybe we could also try something like 2/3. It returns a fraction. Notice that we can also return the numerator using p as a method here, and we could also return q, the denominator. So p and q are used for the numerator and denominator of this rational function. We're going to make use of that a little bit later. So let's go ahead and define our function def, and I'm going to call this uppercase f to uppercase m, and our function is going to have two arguments, a numerator and a denominator. Now I'm going to let f be assigned to the rational function, which is going to grab that numerator and denominator value from the as arguments. And let's just try it out. So this is going to just return f. So let's go uppercase f to uppercase m. Our two arguments 2 and 3, and it returns a fraction. It does exactly what we'd expect it to do. Essentially, we're just using that rational function. Now, what we need is to make a decision. In fact, we need to break this up into two cases, case 1 and case 2. Case 1 is going to be the case where our fraction is an improper fraction. And in this case, we're going to have to do some work. But the second case will just be all other cases. In fact, that will be the easier case to deal with. So for case 1, if the numerator is greater than the denominator, and that's strictly greater than, we have an improper fraction. And if this is the case, we are going to produce some output. And for now, I'm going to let this just be a print function, and we'll give it a string need to fix this. So let's move on to the easier case. So all other cases, we have else. And in this case, we are going to output yet another print statement. So I'm going to use a print function here, and this is going to be an f string, so a formatted string, and we are going to grab f. Notice that f is the rational function here. And now, obviously I need to return output now. So let's go ahead and try this. It does exactly what it did before. However, if I try to give it an improper fraction, it tells me I need to fix this. So we're going to have to do a little bit more work because we actually wanted to output the mixed number here. So we have a couple of things that we're going to need. We're going to need an integer part and a remainder part to generate this mixed number, and then we're going to put it all together partially with this fraction part. So let's talk a little bit about this integer part of our mixed number. Now, let me just try something like 3 divided by 2. Well, that returns 1.5, and what I'm really interested in is that integer part. So what we can use is this integer division function, or we can use this also known as floor division. So we can see here 29 integer division by 6 gives us 4, otherwise it would give us 4.83, and all we're interested in is that integer part. So we could write this as n integer division d, but we've already saw that we have access to f here, which is our rational function. So just to show you that you can do this, you could use nd here, but we're going to take our rational function f, and we're going to call both the numerator and the denominator using p and q respectively. So that's going to generate the integer part of our mixed number. Now the next thing we're going to need is the remainder part of our mixed number, essentially the numerator of the fraction. So if I go 29 divided by 6, I want to be able to express that remainder as an integer. So to do this, we can make use of the modulo function here, and this is going to return the remainder. So 6 goes into 29 exactly 4 times, and then there are 5 left over. So we can use f.p and then modulo and then f.q to get the denominator. So now we have that remainder part. So now what we can take a look at is our output statement. We no longer have to say we need to fix this. We can turn it into an F string. And the first thing that we're going to need is the integer part. So I've placed that first. And then we're going to need the fraction part, which is going to need the rational function. So it's going to be a rational value or a fraction, and it's going to have a numerator and denominator. Now the denominator could be d, as that was one of our arguments, but we're going to call this as f.q. And then the numerator is going to be that remainder part. So we can go down here and place that in a frac part, and let's just run this to see if it works. And we have an error here. We have a spelling error here. So let me just uppercase that P, run it again, and yeah, now it works. So now we can see that 3/2 can be expressed as 1 1/2. So it looks as though it's working. Let's try another one. Let's go back to the one we've done before here, 29 6. And so we see the integer part is 4, and the remainder part is 5. Now, if you want, you could change the notation so that you're adding the fractional part to the integer part, and you might want to use some parentheses there. But in this case, we were looking for a mixed number, so I think that will be good enough.